Find the standard deviation of the following data 5347. Before going to calculation, you should understand there are two formulas for standard deviation. That is, these are two formulas. Now, there is only one difference between these two formulas. That is, in the first case, you should use n in the denominator, and in the second case, you should use n minus 1 in the denominator. If you have data of whole population, you should use n in the denominator. If you don't have data of whole population, then you should use n minus 1 in the denominator. That is, if you only have sample data out of this total population or entire population, you should use n minus 1 in the denominator. Or if you only have certain data out of this whole population, then you should use n minus 1 in the denominator. Now, example for the first is, calculate the standard deviation of first 5 natural numbers. Here, first 5 natural numbers means 1, 2, 3, 4, 5. So, you have data of entire population. Then, you should use n in the denominator. And second example is, find the standard deviation of the following data set 32714. And here, 32714 is the whole population. So, you have data of whole population means you should use n in the denominator. But in the second case, example is, there are 39 plants in the garden. And out of this 39, heights of 5 plants are given. Then calculate the standard deviation of their heights. Which means, here 39 is the whole population. And out of this 39, heights of only 5 plants are given means you only have certain data out of this entire population or whole population. Which means you should use n minus 1 in the denominator. If you have heights of this all 39 plants, you can use n in the denominator. But here you only have heights of 5 plants out of this 39. So you should use n minus 1 in the denominator. Now the second example is, consider you are calculating standard deviation of the population. You are calculating standard deviation of the entire population. But if you have data of all this population, this entire population, then you can use n in the denominator. When you calculate standard deviation of this whole population, if you have data of this whole population, then you can use n in the denominator. But if you only have data of sample population, then you should use n minus 1 in the denominator. So, if you have full data, then you can use n, and if you only have sample data, you can use n minus 1. So, this is the difference between these two equations. Now, we can calculate the standard deviation of the given samples 5347. Here, number of samples is equal to 4, and now calculate the mean of the given sample. Mean means average of the given samples, which is 5 plus 3 plus 4 plus 7 is 19, and total numbers are 4. So 19 by 4 is average. Now take the difference between each of the given sample and the mean of the given sample, then square it. That is, here 5 minus 19 by 4. Take the difference. Then take the square of it, which is equal to 4 into 5 is 20, 20 minus 19, 1. So 1 by 4 square is equal to 1 by 16. Same way, 3 minus 19 by 4, then square it. 3 into 4, 12, 12 minus 19, 7. So 7 by 4 square is equal to 7 square is 49, 4 square is 16. Now again, 4 minus 19 by 4, the whole square is equal to 4 into 4, 16, 16 minus 19 is 3. 3 by 4, the whole square is 9 by 16. Again, 7 minus 19 by 4, the whole square. 4 into 7, 28. 28 minus 19 is equal to 9. So, 9 by 4, the whole square is equal to 81 by 16. Now, take the sum of all these terms, which is equal to 1 plus 49, 50, 9 plus 81, 90. So, 90 plus 50 is 140. In denominator, you have 16. So, sum is equal to 140 by 16. So, here, standard deviation formula is equal to square root of sum of square of difference between each of the given sample and mean of the given sample divided by total number of samples. That is, standard deviation of given sample is equal to square root of sum of square of difference between each of the given sample and mean of the given sample divided by total number of samples. Now this is equal to square root of 140 by 16 divided by n is equal to 4. Now 4 goes 3 times in 12, remaining 20, 3 goes 5 times in 20. So here I can round off to 2 decimal places. So consider root 35 as root 36, which is equal to 6. And here root 16 is 4. Now this is 3 by 2, which is 1.5. So your value is around 1.5, means option 1 is your answer. That is 1.48 is the standard deviation of 5347.